Since its launch in 2009, NASA's Lunar Reconnaissance Orbiter has been gathering incredible amounts of data about the Moon. This information has led to many scientific discoveries, shedding light on the Moon's history, composition, and potential for future exploration. One of the most heavily used instruments on LRO is its high-resolution camera system, which is able to capture incredibly detailed images of the lunar surface. By analyzing these images, scientists have been able to gain new insights into the Moon's geology and its evolution. For example, LRO has provided new data on how the lunar surface changes as a result of the formation of impact craters. During its years orbiting the Moon, LRO's camera has captured the immediate results of meteorite impacts on the surface, such as scattered debris and ejecta patterns on the surface. And since the Moon lacks an atmosphere, these newly formed craters remain essentially untouched over many years, allowing LRO to continuously measure and collect data on them. This means scientists can analyze a crater formed a year ago and use it to learn about craters that formed millions or billions of years in the past, giving us clues about the Moon's geologic history. We can't replicate this type of study on Mars or on Earth, since atmospheric conditions like wind are rapidly changing the surface. The Moon is therefore a unique environment for learning about our solar system. Another major focus of LRO's mission has been the Moon's South Pole. This region is of particular interest to scientists because of the detection of water, which will be a vital resource for future missions to the Moon. The data LRO has collected allows scientists to create detailed maps of the South Pole, leading to the discovery of large regions that appear to contain significant amounts of this water. These discoveries are important because they could help make future missions to the Moon more sustainable. Instead of having to bring all their own water with them, astronauts could potentially extract water from the lunar soil and use it for drinking, cooking, and even rocket fuel. The Lunar Reconnaissance Orbiter spacecraft is also equipped with a suite of scientific instruments that aid in exploration, including a laser altimeter called LOLA that is able to measure the precise elevation of the lunar surface. Using LOLA, scientists have been able to create the most accurate map of the Moon's topography to date, as well as improved lunar gravity models, both of which will help future exploration efforts. Finally, data from LRO has helped us better understand the composition of the lunar surface, shedding new light on the Moon's history. The data has shown that a wider range of compositions of volcanic rocks exist on the lunar surface than previously thought. We have found compositions of rocks that are not part of the Apollo sample collection, and evidence for volcanic activity that may have occurred only 50 million years ago. That's 950 million years after scientists had previously thought it ended. This information helps us piece together a geologic history of the Moon from just after its formation to the present day. Information that will aid in understanding future samples collected by Artemis astronauts. Thanks to the incredible data gathered by the Lunar Reconnaissance Orbiter, NASA and the scientific community are making incredible strides in our understanding of the Moon. With every new discovery, we are one step closer to unlocking the secrets of our closest celestial neighbor.